Okay. So you always want to position it on the lowest energy place because I know ortho is 63% and meta is 3 and para is 34. So are you talking about here? Okay, so yes, you always want to go to the most favorable position. And so for this one, like you said, well, okay. So for this one, I don't know what you mean by 63% versus 34%. But like in this case specifically compared to the purple one, the ortho position is going to be the least likely, or the para position's already taken. But between ortho and meta, ortho will be less likely because it's going to be more electrophilic than the meta position. So when the benzene goes to do the next reaction, it's not going to attack with these carbons, it'll attack with one of these carbons. If you're talking about like in general, if something is ortho-para, like do you choose ortho over para, that's when he kind of does the percentages, like technically ortho is more likely because there's 2 ortho positions, but para is more favorable because of steric hindrance, so it ends up balancing out to be 50-50. I'm not sure if that's what you meant or if that answered your question, but that's kind of what I got from what you asked. Okay. Okay, cool. So, good. So back to this one, I got super distracted, so that's my bad. Okay, so since it is an activator, is it ortho-para-directing or is it meta-directing? Ortho-para, exactly. All right, so what about this group? Weak activator, exactly. And where does it direct? Ortho-para, exactly. Cool. So between the two of these, which one is going to be the director? AKA, which one is the more active one? Green, exactly. So green is going to be the director because it is more activating than our R group. So since it is ortho-para directing, I'm going to put an arrow at the ortho positions and the para position. But this is a perfect example to give you, sorry about my dog screaming. This is the perfect example to show you a point that's very important, so please pay attention. We have one position right here, ortho, that is in between 2 substituents, right? While that is ortho and it's technically favorable because of our directing group, because it is between 2 substituents, it is too sterically hindered to happen. So this will never occur because it is in between 2 substituents. And I can repeat that for you guys because I know there was a lot of noise in the background. So even if the directing group directs between 2 substituents, that will never happen because it's too sterically hindered. So for the purposes of this class, you're never going to add a 3rd substituent in between 2 groups that already exist on the benzene ring. Okay, any questions about that? Does anyone want me to repeat it or explain what I mean or anything? Because it's really, really, really important. If not, we can keep going. Okay, so we will have 2 final products. That was so ugly. We have these two substituents. And according to our directing group, we have two options. So we can either add the bromine here, or we can add it here. And both of them are equally as likely, approximately. And someone said, so there's no preference between ortho and para of the stronger activator. Pretty much no. We know that this ortho position can't happen, but between this ortho and the para positions, Dr. West usually says it's approximately 50-50. I'm sure if you look into like more chemistry stuff, there will be a difference, but for this class, don't worry about it. It's 50-50. Okay, so we have NH2, which is what kind of group? Activator, deactivator, what do we think? It is an activator. Cool. It's actually the strongest activator that we have. Someone said that in the chat. Exactly. So we know that it has to be an ortho-para director. And then we have our chlorine, which is what group? Activator, weak deactivator, strong deactivator. What do we think? Exactly. It's a weak deactivator, which is very important because it's the only weak deactivator. And someone said it in the chat. It's special because it's still ortho-para directing. Exactly. You guys are killing it. So they're both ortho-para directing, but which one is the strongest activator? Green or purple? Green, exactly. Okay, so compared to the green, we have ortho and para, but para is already taken. So our only possible answer is going to be substituted at the ortho position. Sorry, I blinked for a second. Ta-da! And we know that it could have been attached to the other side. I just don't want to draw both. But this would be your final product. Any questions? You guys are doing so great. Someone said, if we had Friedel-Crafts alkylation with this molecule, would it still work because of the halogen? So if we were doing like an alkylation, for example, at this point, right? Yes, the chlorine would work, but since we have NH2 on the ring, it's still not going to happen. So, yes, usually chlorine works, but if you have any NH2 or strong deactivator on the ring, it automatically just will not happen. Even if that wouldn't be the director. If that makes sense. Okay, cool. So the next one, we have, let's do this one first. What kind of group is this? Activator, weak deactivator, strong deactivator? What do you think? People are saying activator. Cool. So that means ortho-para directing. What about this one? What do we think? Yes, it's an activator, so it's also ortho-para directing. So now we have to decide which one of these is stronger. And before you even look at the little thing I gave you that has them in order, I want you guys to think about it logically, right? They both have lone pairs. One of them has to share that lone pair with the carbonyl. The other one does not. So which of these do you think is the stronger activator? One person said it, but I want a couple more answers. Cool, so yes. One quick thing though. So what is the functional group name for the? Okay, cool. So yes, this is an ether. It's really, really easy to mix up ethers and esters. So remember, if there's no double bond, it's an ether. If there is a double bond, it's an ester. I mix them up all the time. Okay, so yes, you guys were right. The purple one is going to be more activating because all of the lone pairs are going to, or I should say all of the electron density is going to go into the ring, versus here, the electron density is going to be shared with the carbonyl and with the ring, so it's going to be less activating. Okay? All right, so the purple one will direct ortho and para. As we can see, the other ortho position is already taken. So the benzene rings get worse and worse. It takes everything inside me not to redraw it, but it's whatever. And I'm lazy, so I'm not going to draw it twice. So we will have two answers. We can either add para, or we can add ortho. Any questions? So someone said that in Katrina's session, she said there were 4 possible answers. Did she go like according? Did she give you the possible answers for this one and then for this one? So I will ask her about that. Technically, yes, the other ones are possibilities, but they're going to be very, very highly unlikely, and you don't need to know them for this class. So, yes, all 4 are technically possible, but I would focus on the ones for the strongest activator. Also, thanks for everyone who said hi, Bear, and that he looks cute. He just got a haircut. So he's precious. But to the person who asked about the other thing, does that make sense? And I will ask her about that, just so I can clarify why she showed all 4, but thank you for pointing that out to me. Okay, so the next one, we have this group again. We already said that it's an orthopara activator, so I'm just going to go ahead and write that in. For this one, though, what do we think? Activator, deactivator. Ooh, we're getting pretty much a 50-50 split between strong deactivator and activator, and that's kind of what I wanted. So esters always trip people up. So remember, for the ester, it depends on which side it's attached to. So for this one, it's an activator because it's attached to the heteroatom, but this side is attached to the carbonyl side. So when it's attached to the carbonyl, it's a deactivator. When it's attached to the heteroatom, it is an activator. Questions on that? I know it can be kind of confusing. So if it's attached to the heteroatom, it is a activator. If it's attached to the carbonyl, it's a strong deactivator. So if it's strong deactivator, where does it direct? Meta, exactly. So which of these are going to win, green or purple? And yes, I can repeat that. So esters and amides, which is this group and this group, when they are attached to the heteroatom side, like this one is, when it's attached directly to the heteroatom, it will be an activator because it's directly attached to the heteroatom, versus when it's attached to the carbonyl, it's going to be a deactivator because the carbonyl is deactivating. Okay, so that being said, the green will be the director because it's activating and this is a deactivator. So the activator is ortho para. The para position is already taken. So we have this, and the bromine will be added to one of the ortho positions. Doesn't matter which one, so I'm only going to draw one of them. But we know that technically both can exist. So someone asked, will activators always be favored over deactivators when choosing positions? So yes, is the short answer. And the reason for this is because we're always going to choose whichever group is more activating to be the director. So if it's ever activator versus deactivator, the activator is always going to win. And yes, you're right. Basically, whichever one is more reactive, that one will be the director. Correct. Sorry, my voice keeps like going in and out. I'm recovering from being sick, and it hates me. Okay, so next one, we have chlorine. Chlorine is going to be what? A activator, weak deactivator, strong deactivator? Yes, exactly. So weak deactivator. And what is the importance of being a weak deactivator? Ortho para directing, exactly. For this one, when you guys look at it, I'm not even going to ask you, is it an activator or a deactivator? I'm just going to ask you, when you look at this, is it not disgusting? Like, look at all these charges here. It's gross. So what does it have to be? A strong deactivator, exactly, because look at all the gross stuff going on. Terrible, terrible. And if it's a strong deactivator, where is it going to direct? Meta, exactly. So between these two, which of them are going to be the director? Chlorine, exactly. So that means bam, bam, and bam. So we technically have 3 answers, right? Yes, exactly. That was a trick question. I want to see if anyone would say what you said. Yes, exactly. There's not 3 answers because this will not work because of sterics. You're never going to substitute in between 2 groups. So this is not going to work. We only have 2 answers. I'm glad you pointed that out. All right. So while I'm drawing this, I'm going... Actually, I will say it after I draw it out. All right. So we can either add it to this position, which is ortho, or this position, which is para. And so one thing I want to mention, it's kind of silly the way he does this, but he kind of does it to trip you up. So if he gave you something like this, and he says, theoretically, how many possible positions are there to substitute. Theoretically speaking, how many positions do you guys think there are? 3. Exactly. So in theory, there are 3. But if he asks you, like, to pick the answers, how many possible answers will there actually be? 2. Exactly. So there's a question that he likes to give you guys that's literally just, he gives you something, and he says, theoretically, how many possible positions can we brominate? 3, technically, theoretically speaking. But if he gave you this and asked you to perform a bromination, there will only be 2 correct answers. If you need me to repeat that, let me know. Just watch out for that theoretically word. If we're good, let's go on to the next one. So, in green, we have SO3H. What kind of group is that? Activator, deactivator, strong deactivator, yes. And so that directs where? Meta, cool. And then here we have our R group, which is an activator. And it is weak, it's pretty weak. Where does it direct? You guys were already answering before I got the words out, awesome. So it is orthopara. So what's gonna win? Green or purple? What's the deactivator? I mean, what is the director? Purple, yes, exactly. So compared to the R group, we have ortho and para. The second ortho position is already taken. So, wow. Our 2 possible answers will be ortho and para. I believe that's the last example. Yes. So, do you guys have any questions? Someone said, I think I'm a pro now. Heck yeah, you are. I'm so happy that you said that. Okay, so if there's no more questions, we're about to do my favorite part of this chapter. I made it kind of like a game. So we're going to play Build That Benzene. And I'm going to put you guys into groups. We're going to do like breakout rooms. So I don't think this will stay up when you go to your breakout room. So please take a screenshot or a picture or something so you guys can still see it when you go to your rooms. I'll give you a second to do that. And so basically what you guys are going to do is each group is going to go through. I'll give you guys like 10 minutes and I'll pop into all the rooms just to see how you guys are doing. And you're going to essentially try to answer all of these. Try is the key word. You don't have to have them all done. But the group that gets the most, or I'm trying to think about how this would work virtually, but the group who does the most of them correctly will get like a little prize. I don't know what it'll be because again, we're virtual, but I'll figure something out. And you'll be a winner. So essentially how you play the game is, I'll zoom into one of them. So these answer choices are all the reagents that you use to add something to the ring. So you're going to go here and there's 1 and 2. And so you're going to add which one of these were added to the ring first. So it's a retrosynthesis, right? So we'll do the first one together as an example. And I'll show you the answer choices. So for this ring, which one had to be put on first? I'll see what you guys think, and then I'll show you my way of doing it. So people were saying A, so chlorine would be added, and let's see if that's correct. So we're essentially going to go through and do the same thing that we did before. So we know that chlorine is a weak deactivator, so it's ortho-para-directing. And we know that NO2 is a strong deactivator, and it's meta-directing, right? That's just from our table that we had before. That's something that we know. And so we also know that these two groups are what to one another? O, M, or P? What are they? Para, exactly. So if these are para to one another, that means chlorine had to be on there first, and then NO2 was added second, and that is C. Any questions about how the game works? We good?
I have a question.
Yes.
So what did you mean, like, because they're para to each other, chlorine had to be first?
Great question. Okay, so you're essentially going backwards and you're telling me the order that things were added to this ring. And so since these two groups are para to one another, they're on opposite sides of the ring. If we had added NO2 first, so like we had a blank benzene ring and we add NO2, there's no way that the chlorine could be added para because we know NO2 is a meta-director. So since they're para to one another, we know that chlorine was added to the benzene ring first, and then after chlorine was added, then NO2 was added. Does that make a little bit more sense?
Oh, yeah, I see. Thank you.
Good, you're very welcome. Okay, so I'm going to put you guys into groups now. I'll zoom out in case you need to take a picture or something. And I will put you guys into breakout rooms. And then someone had asked, how do I know which one was added first? Did that explanation help, or do you want me to repeat it? Because I totally can. I just hadn't seen your thing. Meeting, breakout room, enable breakout rooms. And yes, I can repeat it while I do this. So essentially, we know that the chlorine had to be added first because the groups are para to one another. If we added chlorine second, it would have to be meta, because if NO2 was added first, it is only a meta-director. If chlorine is added first, we know that NO2 can come afterwards and be on the ortho or para positions. So that's why we know chlorine was added first, since the second group was added para to it. Okay, so let's do 5 groups. So there's like 4 or 5 people in each one. And I'm about to start the sessions. Does anyone have any questions before I put you guys in your breakout rooms? Okay, so I'll give you guys like 6-ish minutes. I'll come in and I'll see how you guys are doing. You don't have to finish them all. Just try your best to do as many as you possibly can. And then we'll go over it together. So I'm starting the sessions now. Calm down, babe. Alrighty. Breakout session. Let's bring everyone back. So someone said, I had a quick question. Was there a CH3 Frito Crafts alkylation? It was supposed to be CH2, CH2CH3. So the last two that have just CH3, that was just my bad. So I apologize. I didn't notice that till just now. Oh my god, I hate it. Okay. And yeah, thank you for pointing it out. I see how that would be confusing. Okay, so I'm going to end the breakout session and bring everyone back. So I'll give it a second while people are coming back here. Okay, cool. So it's giving them like 30 seconds and it's bringing them back. So as you guys come back in here and we wait for everyone else to return, let me know if you have any questions. And let me know what you guys thought. Someone said that it was fun, and I'm glad. I hope it was fun and it wasn't just really annoying. I know it's hard to use WebEx sometimes, but so it's a good practice, yay. It's really fun in person because I just pass out markers and then it's like a Hunger Games kind of thing where everyone just like runs to the board and tries to answer it as fast as they can. Okay, so I wonder if you guys can do that on here. I know you guys can write on the thing, but I don't know how to. It's too much work. We're not going to do that. Also, I know that it's 11:57. If anyone's super confused and like, oh, she ran way overtime, we are doing an extra hour today because stuff. We were behind. Yes, question? Someone unmuted if you have a question. Give her a second.
I have a question.
Yes, okay, what's up?
When it came down to the, okay, well, I guess we're gonna get there, but when it came down to the last ones, it was kind of hard to really pick because when you had like three groups going on, it it kind of got like tricky.
Yes, and you're totally right. These ones I gave you guys to be like not super super complicated, but like like more complicated than the rest of them, just so you guys have like these harder ones to practice with. If you guys can do these, you're gonna be like 100% set for the exam because the exam is gonna be a lot more straightforward than these ones.
Okay.
Okay, so technically, if I do a second hour, we're supposed to hop into a new session, but I really don't want to do that. Do you guys care if we just hop into another session? Did I send a sign in? Yes, I think I did, but I'll send another one. Okay, so if you guys are okay with it, if you guys are fine, we'll just end this session and we'll do the answers to these in the next session. It's already up on Canvas. Just click enter. And trust me, I know it's super annoying, but